Hello and welcome to the course of manufacturing method. In this class, we will be studying about unconventional machining process that is based on chemical and uh, thermal energy. So, unconventional machining process based on chemical and thermal energy. So, in the last class, we have discussed about the unconventional machining process based on electrical energy only. Now, in this class, we will be talking about the unconventional machining process based on chemical and thermal energy. The lecture objective here is to get an insight about the thermal and chemical energy based unconventional machining processes and to know about the working principle, advantage, disadvantage about different unconventional machining processes. So let's start with chemical energy based process. The chemical energy based process means those processes which uses chemical energy to remove the material from the workpiece. So the example of this process is chemical machining or CHM. In chemical machining this chemical machining, and there is another type that is known as electrochemical machining, where material is removed by ion displacement of workpiece material in contact with chemical solution. The example of the electrochemical machining is electrochemical machining, electrochemical grinding, electrochemical honing, and electrochemical deburring. The chemical machining, or it is also called chemical milling. Here a maskant and etchant are given. The mainly whole workpiece is put under the chemical reagent, and by reacting with that reagent the material of the workpiece will be removed. And there is one etchant. The use of etchant is to remove the material from the workpiece, and the maskant, there is a maskant are provided. Maskant are used to mark the places where the we don't want any material to be removed, that is maskant. Now, application of chemical machining. The chemical machining used in manufacturing of bar free component. This chemical machining is applied where the depth of the material removal is critical to the few micron, and the tolerances are close. Disadvantages. What are the disadvantages? The disadvantages are, in this chemical machining the MRR is low, manufacturing cost is high, large floor area needed, it is not possible to produce sharp corners, workpiece thickness can be machined is limited. What are the advantages of chemical machining? The advantages of chemical machining are bar free component can be produced, most difficult to machine component can be machined, high surface finish is obtained, and stress free component are produced. No need for skilled labor, the tooling cost is very low, complex contour integrate shapes can be easily machined, and hard and brittle material can be machined. Both the faces of the workpiece are simultaneously machined by using this chemical machining. Now, electrochemical machining. In this electrochemical machining, that is based on the electrolysis. So, as per the Faraday's law, amount of material dissolved or deposited is proportional to the quantity of the electricity passed. This is first law of Faraday, and second law of Faraday says that the amount of the charge that produced in material is proportional to the electrochemical equivalent of the material. So workpiece is connected to the positive terminal, that is called cathode, and the tool is connected to the negative terminal, that is called anode. See here, workpiece is cathode, workpiece is anode, and your tool workpiece is connected to positive cathode, and tool is connected to negative terminal, that is anode. So by this setup electrochemical machining can occur. Here only the concept of electrolysis are taken. So by taking this advantage of this electrolysis, electrochemical machining is happened. And in electrochemical machining, the applications are to machine complicated profiles like jet engine blade, turbine wheels, to drill small and deep hole in nozzle, to machine cavities and hole of irregular shape, to machine blind hole and pockets in forging dies, to machine hard and heat resistant material. This is the use of electrochemical machining. Now limitations. What are the limitations? The limitations are sharp internal corner cannot be machined by using this process. Post machining cleaning is needed. Tool design is very complicated. Control mechanism is needed to maintain high tolerance. What are the advantages? The advantages are, here MRR is high, wear and tool tear is negligible, machining is done at low voltage, intricate and complex shape can be machined very easily, machined work surface is free of stress, no cutting force is involved, high surface finish of order 0.2 to 0.8 micron is obtained, and the tolerances of 0.005 mm can be obtained. No bars are produced. In case of electrochemical grinding, materials that cannot be easily shaped due to their extreme hardness can be ground very easily. The example is high hardness material, for example cemented carbide and hardened steel, that can be very easily grounded by using electrochemical grinding. The principle is the work is machined by combined action of electrochemical effect of conventional grinding operation. See here, the conventional grinding operation along with the electrolysis, when both the thing acts together or the advantages of both the process are clubbed together, at that time we can say that the process is electrochemical grinding. In case the application of electrochemical grinding can be seen in case of high precision grinding of hard metal like tungsten carbide, and it is also suited for to cut the thin section of hard material without any damage. So thin section of hard material can be cut by using the also suited without any damage. Advantages of this electrochemical grinding is to tool wear. The advantages are the tool wear is very negligible, work is free of surface crack and not subjected to any structural changes, bar and stress free components are produced, good surface is obtained, surface finish of 0.2 to 0.4 micron are produced, accuracy of 0.01 mm can be achieved, intricate path can be machined without any distortion. Disadvantages of electrochemical grinding can be seen as initial cost is very high, power consumption is high, MRR is low, non-conductive metal cannot be machined, maintenance cost is very high, tolerance achieved is low, preventive measures are needed against the corrosion of electrolyte. Now there is another type, that is thermal energy based process, where heat energy is concentrated on a small area of the workpiece to melt and vaporize the tiny bits of the work material, and the required shape is obtained by continued repetition of the process of vaporization and evaporation. That is the process of that is the principle of the system based on thermal energy. So the examples are electron beam machining EBM, laser beam machining LBM, plasma arc machining PAM. So we will be studying all of these three machining processes one by one, and along with their application, advantages and disadvantages. So let's start with electron beam machining. Here a high energy electron beam is focused into the place where we need to remove the material by melting and evaporation. So melting and evaporation is the process, and that melting and evaporation, heat required for that melting and evaporation is supplied by the high energy or high velocity electron that is flowing, that is traveling at half of the velocity of light, are focused into the workpiece. So this is the electron beam machining principle. The main working principle is, when high velocity electron beam strikes the workpiece, the kinetic energy in the electron beam is converted into heat, and this concentrated heat rises the temperature of the workpiece and it vaporizes a small amount of it, resulting in removal of material by evaporation from the workpiece. So this is the principle of the of your electron beam machining. Now see, in this figure you can see that electrons are coming from the electron gun, and that is focused into the workpiece by reflective mechanism, that is magnetic lens, and that this whole process is kept on a vacuum, because if there is no vacuum, there is air molecule, electron may be very easily scattered from their place, and so we cannot get this much focused stream of electron or focused jet of electron. So this is the picture. Now applications of the electron beam machining is this: electron beam machining is used for micro machining operation, used to drill hole in pressure differential devices, used to remove the small broken tap from the hole, used to machine low thermal conductivity, high melting point material. Advantages of this electron beam machining is, this process is excellent for micro machining. Very small hole and hole of different size can be machined. No mechanical contact between the tool and the workpiece can be seen. Quick processes, the process is very quick. Process can be very easily automated. Close tolerances are obtained. Brittle and fragile material can be machined. The physical and metallurgical damage of to the workpiece are less. Disadvantages: MRR is very low. Cost of the equipment is high. This process is not suitable for large workpiece. Little taper is produced on the whole. Vacuum requirement limits the size of the workpiece. No, this process is not suitable for producing perfectly cylindrical profiles. Applicable for all the thin material, and energy applicable for only the thin material, and energy consumption in this process is very high. Now laser beam machining. Laser means light amplification by stimulated emission of radiation. Laser beam also, high energy or high power density laser beam is focused into the workpiece to melt and evaporate the material from there. So laser beam is focused on the workpiece by means of lens to give extremely high energy density to melt and vaporize the work material. This is the principle, and it can also be used to drill micro hole up to 25 micron, and this laser beam process won't require any vacuum, because by the nature of the lasers are very high density monochromatic and directional rays. So this is the process where the lasers are coming by from resonance cavity. These lasers are coming through the lens to converge at the point, and at that point where the convergence occurs, at that point the material will be removed in the form of vapor, So this is laser beam machining. Machining application of the laser beam machining can be seen in case of metal cutting, drilling, welding, conduction limited or deep penetration welding, surface treatment, and other applications such as sheet metal trimming, blanking, register trimming, etc. The advantages of LBM are: micro-sized hole can be produced, soft material like rubber can be machined, there is no tool wear, no direct contact between the tool and the workpiece, dissimilar material can easily welded by LBM. This process can easily automated, and hardness of the material does not affect the process. Heat affected zone is very small. Deep hole of short diameter can be easily drilled by LBM. Disadvantages of this LBM process are: the initial investment is high, operating cost is also quite high, high skilled operator are needed, rate of production is low, safety procedures be followed very strictly, overall efficiency is extremely low, and life of flash lamp is very short, machined hole is not round and straight. These are the disadvantages of LBM process. And now plasma arc machining or plasma jet machining. Here the material is removed by directing high velocity jet of high temperature ionized gas to the workpiece, which in turn melts the material from the workpiece. So high temperature ionized gas of the gas is supplied to the workpiece at high velocity. This is called plasma, and this process is known as plasma arc machining. The application is used for profile cutting, used for turning, milling, and milling to hard to machine material. It can be used for stack cutting, shape cutting, uniform thin film spraying of refractory material can be done by this. Used to cut the alloy steel, stainless steel, copper, nickel, titanium, aluminum, and it's their alloy of and the alloy of copper and nickel. The advantages and disadvantages of this process are shown here. The advantages are: this plasma arc machining is used to cut material. Cutting rate is very high. It can cut the plain carbon steel 4 times faster than ordinary flame cutting process. Used for rough turning of very difficult material. Disadvantages: the process produces tapered surface, noise protection is necessary, equipment cost is very high, protection of eyes is necessary for the operator, and work surface may undergo metallurgical changes. Thank you, that's it, and I hope every process has been completed in this topic, and have a good day. If you have any question, you may ask in the live class.